Jupiter doesn't just dominate with its size or storms. It rules with an invisible force field so vast it could engulf the Sun. This is the magnetosphere of Jupiter, and today on Infinity Beyond, we'll uncover how this giant magnetic domain shapes the entire Jovian system, and why it's unlike anything else in the solar system. Jupiter's magnetosphere is the largest and most powerful of any planet, stretching as far as 7 million kilometers toward the Sun and flaring out to 650 million kilometers on the night side. That's nearly to the orbit of Saturn. Its magnetic moment is 20,000 times stronger than Earth's, generated by the motion of metallic hydrogen deep within the planet's interior. One key to understanding this immense force field lies with its moons, especially Ganymede, which has its own mini-magnetosphere embedded within Jupiter's. Scientists believe that tidal forces in Ganymede's early history stretched and heated its interior, warming the core and possibly preserving the magnetic field we observe today. That same force may have also played a role in maintaining its subsurface ocean. Jupiter's magnetic field lines trap charged particles, creating radiation belts far more intense than those of Earth. These particles bombard nearby moons like Europa, Io, and Ganymede, creating high-energy environments that challenge spacecraft and shape surface chemistry. One of the most stunning effects of this magnetosphere is Jupiter's auroras, the brightest in the solar system. These glowing ovals of ultraviolet light dance around the poles, created by interactions between the magnetic field and incoming solar wind. But unlike Earth's auroras, which come and go, Jupiter's are constant and fueled by its moons. Io, with its intense volcanic activity, constantly spews material into space. These particles are ionized and swept up by Jupiter's magnetosphere, forming a plasma torus that circles the planet. As these charged particles move along magnetic field lines, they funnel into the polar regions and trigger dazzling auroral emissions. What's remarkable is that scientists have used auroras to map what's happening deep inside Jupiter and its moons. For example, the presence of auroras at certain latitudes on Ganymede confirmed the existence of a subsurface ocean, without needing to dig or drill. Magnetic reconnection events, where magnetic field lines snap and reform, also tell us how energy is transferred throughout the system. The magnetosphere isn't just a scientific curiosity. It's a critical piece of the Jovian environment. It affects spacecraft navigation, radiation shielding, and even the potential habitability of the moons. Any future missions to Europa or Ganymede must plan around the intense radiation zones shaped by Jupiter's magnetic field. Spacecraft like Juno have flown through the magnetosphere, carrying instruments to measure particle density, magnetic field strength, and auroral patterns. These data are helping scientists model the structure and dynamics of this vast magnetic domain and better understand the internal engines driving it. Jupiter's magnetic field also gives us clues about planet formation. It suggests a deep layer of liquid metallic hydrogen, formed under pressures millions of times greater than Earth's atmosphere. As this material moves, it generates electric currents, and those currents create the magnetic field. By studying how the field changes over time, we can infer what's happening inside the planet, far beneath the visible clouds. Some of the most exciting moments in the Juno mission occurred when it plunged into the magnetotail, the region where the magnetosphere is stretched out behind Jupiter, like a comet's tail. Here, reconnection events and particle acceleration reveal how energy flows outward from the planet into space. As we look to exoplanets beyond our solar system, magnetospheres become even more important. A planet with a strong magnetic field can protect its atmosphere from being stripped away by stellar winds, a key factor in maintaining habitability. In this sense, Jupiter is more than just a giant, it's a template for what we might find around other stars. Back here in our own system, The magnetosphere links Jupiter and its moons into a single dynamic machine. It creates electrical currents, powers auroras, and shapes the very surfaces of its satellites. As we conclude this segment on Infinity Beyond, we now turn to the cutting edge of exploration. Juno's recent discoveries and how they're revolutionizing our understanding of Jupiter's interior, weather, and auroras in ways never before imagined.